Today we are going to discuss the second and last part of the physics chapter, gravitation. So let us discuss. As already discussed, that the universal law of gravitation states that the force of attraction between any two objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Now we this can be mathematically written as following. If we consider two bodies, let us assume they may be A and B, and F be the force acting on these bodies A and B, and M1 and M2 be the mass of A and B. So this can be written according to the universal law of gravitation as follows. That is, product of mass m1 and m2, the z force is directly proportional to the product of their masses, that is m1 and m2. And inversely, when it is inversely, then it comes in the ratio 1 by r square. R is the distance, square of distance, so F force is inversely proportional to the square of distance. It can be written as F is equal to m1 m2 divided by r square, or F is equal to g m1 m2 divided by r square, while g is known as universal gravitational constant. It is a constant whose value is 6.67 into 10 raised to power minus 11 newton meter square kilogram square. After that is acceleration due to gravity. Simple words, we can say the acceleration is due to the earth's gravitational force, therefore the acceleration is called acceleration due to gravity, because this when a body falls towards earth, it is attracted by the earth towards itself due to a gravitational pull, due to which this acceleration is called acceleration due to gravity, and it is denoted by a small g, while universal gravitational constant is denoted by a capital G. Their values are also different. The value of g that is acceleration due to gravity, 9.8 meter per second square. So after that we will discuss factors on which this acceleration due to gravity depends. That is, acceleration due to gravity is directly proportional to the mass of the earth and inversely proportional to the square of the radius of the earth. So therefore this acceleration depends upon the product of masses of two bodies and distance, that is inversely proportional. After that we will discuss free fall. In simple words, we say whenever an object falls towards the earth under the influence of gravitational force, we say that the object are in free fall. As free falling body has acceleration, and this acceleration there will be when it or object falls, there will be change in the magnitude of velocity. This velocity involves acceleration, therefore this acceleration is called acceleration due to gravity for a free falling object. You can take an example. The picture shows free falling objects. Anyone, like we can also give example of an apple which falls towards the earth. This apple's fall is free fall, as it falls under the influence of gravitational force or gravitational pull of the earth. There it is. The body having a free fall is called freely falling a body. Galileo proved that the acceleration of an object falling freely towards the earth does not depend upon the mass of object. So this whatever be the mass, the object which freely falls on the earth will reach the earth at the same time. This has been shown by Galileo. After that we will give some signs which are used in this physics. The physical quantities having vertical upward motion, so they are assigned positive values. Unlikely those which are having vertically downward motion, these are having a negative value. That means the object which moves upwards have positive values and which comes downwards has negative values. Acceleration due to gravity always acts in downward direction and hence taken as negative, because the acceleration due to gravity is gravitational pull which is posited by the earth. G is always taken negative, that is acceleration due to gravity. When a body is dropped freely, its initial velocity remains zero. So when a body is thrown vertically upwards, its final velocity becomes zero, because at some time it will uh, rest and will start falling downward. The time taken by a body to rise is equal to the time it takes to fall from the same height. This is your gravitational chapter. After that we will discuss another chapter, that is sound.